The first time I walked into a carriage shop outside Mount Hope in Holmes County, Ohio, in the middle of August, I expected noise. What I found instead changed something in me. The air smelled like cut oak and linseed oil. The light came through dust in long gold bands. Outside, the gravel burned through my boots. Inside, the loft felt cooler than the yard, and the only steady sound came from steel turning above me in the roof. I stood there for 11 minutes looking for the extension cord. It was not there. No fan motor, no humming inverter, no hidden line running down a wall. And that was the moment I understood I had been wrong about what simple buildings can do. What hit me was not some miracle machine. It was a quiet old roof spinner doing two jobs at once. It was moving heat out of the building, and it was making a small stream of useful power from the same motion. Not enough to run your whole house, enough to matter, enough to change how you think. I have been going back to Holmes County every autumn for 3 years, and every time I find something the building industry forgot on purpose. This video makes one promise. By the end, you will understand why a roof-mounted turbine that published testing has pushed to 17.5 watts at 200 revolutions per minute still gets treated like a curiosity instead of a household tool. And yes, this works even if your house was built 50 years ago, you live in a city, and you have never done this before. Stay with me, because what I found in Holmes County uses the same physics the Persians used to pull heat from desert rooms more than 1,700 years ago. Nobody told you, not your builder, not your contractor, not the man who sold you another powered fix. The science is simple. Hot air rises. Wind lowers pressure on the lee side of a roof. Put a rotating vent at the right point, and buoyancy plus pressure differential become torque. Add a generator with low startup resistance and torque becomes direct current. That is all this is. Airflow, rotation, charge. The University of Alberta measured turbine attic ventilators in 1993 and found average ventilation rose from 5.3 to 6.1 air changes per hour, with gains from 5% to 50% depending on wind direction. The National Bureau of Standards workshop proceedings from 1979 also made something clear. Powered attic fans often failed to save much because they consumed electricity to chase small thermal gains. This roof approach does not buy the airflow first. Think about a bicycle dynamo rubbing against a tire. Your legs spin the wheel. The dynamo turns that motion into a little current for a light. Here, the attic does the pushing. Heat builds pressure. Wind adds pull. The spinning cap becomes the wheel, and the generator becomes the dynamo. In wind engineering, the equivalent metric is power coefficient. A crude cup-style rotor can capture roughly 0.12 to 0.20 units of the available wind power for every 1 unit moving through it. A static roof cap captures 0. A powered attic fan goes negative the moment you pay 150 to 300 watts to force the air. That is the whole argument in one line. A 2013 rooftop ventilator generator paper in the Journal of Power and Energy Engineering pushed an 8-inch ventilator to 17.5 watts at 200 revolutions per minute with 4 meters per second wind as the reference point. Small number, important number, because the same rotor is also exhausting hot air that your paid cooling system would otherwise fight alone. That gap represents a massive market in equipment, seasonal service, replacement parts, and financed upgrades every single year. And that is why you have never heard of this. Your own body already understands the principle. Sweat works because evaporation moves heat away without asking your skin to manufacture cold. A cast iron radiator works because hot fluid rises and cooler fluid falls. This roof device sits in the same family of physics. It does not create energy from nowhere. It intercepts motion that your house was already producing and turns a thin slice of that motion into something useful. That matters because the paid alternatives add layers you keep funding forever. The U.S. Energy Information Administration says heating and cooling account for nearly half of home energy use. Every degree you keep from collecting under the roof changes the load that follows. Every watt you trickle into a battery from airflow is a watt you do not buy later as emergency backup, charger power, or night lighting. Small systems do not look glamorous. They stack, they multiply, they change habits. And once you see that, the usual objection disappears. You stop asking whether one device can do everything. You start asking whether one simple device can do one honest job for 30 years with almost no attention. That is the right question. The living proof is not in a lab. It is in the buildings. I felt it first in Mount Hope, then again near Berlin, where late afternoon heat sat over the road like glass. I walked into a workshop with a black roof, no compressor outside, no attic fan noise, and a steady draft moving above my face. I asked Eli what his family called the spinning vent. Eli laughed and told me nobody in the house bothered naming it because it had simply been there, in one form or another, for 4 generations. Eli pointed up and said the old men wanted the loft dry, the harness room cooler, and the battery topped when the wind was honest. That was the whole philosophy. Use what already moves. That knowledge did not start in Ohio. It came through families shaped by the Palatinate, Alsace, and Canton Bern before the move into Pennsylvania and then west into Ohio after 1808. The Amish did not read this in a textbook. They figured it out the way all real knowledge gets discovered, by paying attention to what the air was already doing. And the paper trail exists. A U.S. Department of Agriculture bulletin from 1930 on barn ventilation and earlier extension literature on dairy barn ventilation both treated roof-driven draft and ventilator heads as practical farm knowledge, not novelty. What stayed with me was the sound, or really, the lack of it. No condenser cycling, no belt squeal, no powered fan chopping air. I heard boot leather, a horse shifting in the shade, and the turbine ticking faster when a stronger gust crossed the ridge. Then Eli said something I wrote down before I even reached the truck. Eli told me, if a thing needs fuel before breakfast and repair before harvest, it is usually the wrong thing. That sentence explains more American building failure than a shelf full of trade manuals. The timeline fits the movement of the families themselves. Penn State's Amish history timeline traces the first larger Amish migration to Pennsylvania in 1737 and the second wave into Ohio after 1815. The knowledge moved with the people because it belonged to chores, lofts, milk rooms, tax bases, and heat. It was not academic knowledge. It was daily knowledge. That is why it survived. Go back farther, and the pattern gets harder to ignore. In Yazd, Persian builders raised badgirs above adobe roofs so hot air could be pulled upward and out, while cooler air moved below. In summer heat, the air path mattered more than machinery. The tower did not create wind. It harvested pressure. Then look at Rome. The Pantheon left a 27-foot oculus open to move light, smoke, and rising hot air through one of the most famous roofs on Earth. In bath complexes and service buildings, roof openings and stacked paths handled heat because heat always seeks height. Different empire. Same answer. You can cross into East Asia and see the same lesson again in Hanera granary and roof ventilation practice. Moisture had to leave. Heat had to rise. Stored goods stayed safer when builders respected airflow instead of trapping it. Different materials, same physics. Every civilization that mastered extreme heat arrived at the same answer independently. The Amish never forgot. They carried it from the Palatinate and Canton Bern to Pennsylvania and Ohio more than 200 years ago and kept building it because it worked, and because they never needed anyone's permission to do what made sense. And you can feel the insult in that continuity. Civilizations with no compressors, no offshore supply chain, and no glossy showroom still solved the same thermal problem in radically different climates. They did it with clay, stone, timber, vent heads, shaded courtyards, and roof geometry. Then a modern industry looked at the same problem and told you comfort only arrives in financed boxes. That is not progress. That is amnesia with a payment plan. The part that should make you angry starts in 1944. Carrier Corporation made a deliberate move that year to sell packaged air as a household necessity in Life magazine, instead of treating conditioned air as industrial equipment. By 1952, Fortune was reporting $1.25 billion in air conditioning sales. Every house that solved more of its own heat with roof draft, shade, mass, and air path threatened a piece of that money. Then came the mechanism. In January 1942, the Federal Housing Administration inserted a 1 to 300 attic ventilation rule into minimum property requirements with no attribution and no site-specific logic. In 1949, Housing and Home Finance Agency guidance on condensation control cemented that ratio into standard practice. Then the 1958 National Minimum Property Standards went further. HUD's own historical review says the rewrite relied on manufacturers, architects, engineers, more than 150 trade associations, and comments gathered through the National Association of Home Builders. Do you see what happened? A living craft got turned into a checkbox. Once roof ventilation became a fixed ratio on paper, builders stopped reading a building and started satisfying a line item. Climate judgment shrank. Local wisdom shrank. Mechanical add-ons grew. The allies all benefited. Life magazine and later Better Homes and Gardens sold cooled modernity as a dream worth buying into room by room. Carrier later bragged that advertising ran through top national magazines and television. FHA and later HUD linked acceptable housing to standardized assemblies that builders could replicate at scale. Carrier and General Electric sold the machines that completed the picture. Mortgage approval, magazine desire, and equipment sales all pulled the same direction. Look at the timing and the sales curve. The Department of Energy's own history notes that 43,000 home systems sold in 1947. Trade reporting then exploded through the 1950s. Air conditioning and refrigeration news recorded room unit shipments passing 1.04 million in 1953. In 1956, the electricity industry launched the Live Better Electrically campaign to normalize higher household electric use as aspiration. Once summer load became revenue, passive heat control stopped being a hero story. It became competition. An entire field of knowledge disappeared from architecture schools, builder habits, and code culture. Not because it failed, because standardized mechanical comfort paid better. And the continuation never stopped. In Ohio, former First Energy subsidiaries backed what investigators described as a $61 million bribery and influence campaign around House Bill 6 in 2019, a law that protected centralized generation and slashed support for cleaner alternatives. In California, regulators cut compensation for new rooftop solar customers under NEM 3.0 in 2022 after years of utility pressure over customer-owned generation. Different state, same reflex. Keep control centralized. Keep the meter sacred. The heating and air conditioning contractor market in America is worth $159.4 billion a year. Every alternative installed is a compressor, service call, financed replacement, or seasonal bill that never gets sold. Now, if you already own a house and you're thinking this only applies to people with land, stay with me, because this next part is specifically for you. You don't need to rip out your existing system. You need a ladder, a drill, and a weekend. Here is the blueprint I would use if this were my own roof. I would start with a 12-inch or 14-inch aluminum turbine vent, not plastic, mounted 24 to 36 inches below the ridge on the sunniest roof plane. A 4-inch to 6-inch throat is enough for a first build. I would keep the roof pitch between 4 and 12 and 9 and 12 because that is where common flashing kits seal cleanly. Under the base, I would use EPDM flashing, butyl tape, and exterior urethane sealant. Then tie the unit into 26-gauge galvanized flashing so wind-driven rain cannot walk backward under the shingles. Inside the attic, I would bolt a low-cog 24-volt permanent magnet DC motor to a 1/8-inch aluminum flat bar bracket, keeping the shaft dead center and within 1/16 inch of wobble. Then, I would run 14 AW GUV-rated stranded copper through a rubber grommet to a 10-amp fuse and a full-wave bridge rectifier. The bridge rectifier is not optional. Straight wiring causes reverse drag in low wind and can cook a small battery during gusty bursts. After the rectifier, I would feed either a 12-volt LiFePO4 battery or a sealed AGM battery through a simple charge controller set for 13.8 to 14.2 volts. If you want usable output fast, add a 5-volt buck converter for lights, phone charging, sensors, a fence charger, or a router backup line. Costs stay low if you refuse the fancy versions. The turbine itself runs $28 to $46. A surplus motor or low-drag generator runs $18 to $34. Rectifier, fuse, wire, terminals, and grommets add $22 to $41. Flashing, tape, sealant, and stainless hardware add $24 to $38. A modest battery and controller add $69 to $118. Total outlay lands between $161 and $277 if you already own the drill bits and ladder. The install is not a summer-long project. It is one Saturday morning for the roof work and another 40 minutes for the wiring if you pre-cut everything on the bench. On a 95-degree day with a real 10 to 12 mile-per-hour breeze, you should expect a steady trickle in the 6 to 14 watt range from a careful build, while the vent continues moving loft heat without buying a single watt from the grid. In stronger gusts, published prototypes show the ceiling is higher. Maintenance is plain. Check fasteners once a year. Clean dust and insect buildup at the throat every season. Oil the bearing only if the manufacturer calls for it. Most metal turbines last 20 to 30 years if the flashing stays dry. If I were stretching the build, I would add one more layer. I would hang a simple reflective heat shield under the roof deck near the hottest bay, leaving a 1-inch air gap so the vent can keep flushing the space. Low-E radiant foil works. So does bright aluminum sheet if you already have scraps. Then I would weather strip the attic hatch and seal the largest ceiling penetrations with fire-rated caulk. That part matters more than people think. If the attic can vent but the ceiling leaks badly, you are cooling your light fixtures and pipe chases instead of your rooms. I would also be honest about loads. This is not where you plug in a microwave. This is where you keep the little things alive. A modem, a gate opener, a 12-volt circulation fan, security lights, tool charging, sensor batteries, a chest freezer alarm. The magic is not brute force. The magic is that these are the exact loads that become irritating, expensive, and fragile during outages. Cover those first and your whole house feels steadier. There is also a winter use people miss. Cold wind still turns the rotor, and dry winter air still needs movement in loft spaces, sheds, and tack rooms. If you switch the controller output to battery maintenance, the same device keeps doing work when the summer heat is gone. That is why the best traditional systems never solve only one season. They earn their place all year. Your powered attic fan and backup charger setup costs $900 to $2,400 to install, $6 to $18 per month to run, and lasts 8 to 15 years before it ends up in a landfill. This costs $161 to $277 total. It lasts 20 to 30 years. Your choice. Everything I have covered across this channel, root cellar cooling, lime wash walls, hand pump water, I have put in one place, step by step, season by season, room by room, in the order the families actually use it. The link is in the description, but stay here, because what Eli showed me in that loft is the part nobody is talking about yet. One more thing matters, and almost nobody says it clearly enough. Placement beats gadget quality. A cheap turbine mounted over the hottest roof bay with a clean throat and a true exhaust path will outperform an expensive unit dumped in dead air. If you have a long attic, do not guess. Go up there at 4 p.m. on the hottest week you get. Feel where the trapped heat sits. Use a cheap infrared thermometer if you want numbers. Mark the hottest rafters. Mark the stillest corner. That is your map. Then think like a steward, not a shopper. If your soffits are blocked with insulation, fix that first. If a ridge vent already handles the roof well, use this as a charger on an outbuilding instead of forcing a duplicate system. If tree cover gives you almost no breeze, put the effort into shading and sealing air sealing before you cut metal. Honest adaptation always beats copy and paste DIY. That is another reason these families stay ahead. They build to the site they have, not the brochure they were shown. And if you want the simplest first test, do not even wire the generator on day one. Mount the turbine correctly. Live with it for 2 weeks. Listen to the house at night. Check the loft smell after rain. Feel the upstairs ceiling at sunset. Then add the generator once you understand the airflow you created. That order teaches you more than any sales pitch ever will. Once you understand that, the emotional shift is immediate. You stop waiting for a perfect all-in-one answer and start collecting durable advantages. A quieter attic, a drier loft, a battery that stays ready, a roof fitting that earns its keep in July and January. That is how self-reliant houses get built. Not with one miracle purchase, but with 10 honest decisions that keep paying after the credit offer expires. The industry hates that mindset because it breaks the spell. It turns you from a monthly customer into a patient observer. And patient observers notice where the money goes, where the waste hides, and where the old knowledge still works for you now. The biggest misunderstanding is scale. You have been trained to think every energy solution must arrive as a complete replacement package. That is how systems get sold. Real resilience rarely arrives that way. It shows up in layers. A little less heat in the attic, a little stored current by evening, one less plug-in gadget, one less billable dependency, not because it is dramatic, because it compounds. That is why these quiet devices stay invisible. They do not fit the replacement economy. Nobody gets rich selling you a stamped aluminum rotor that turns for decades, asks for almost nothing, and solves a narrow problem well. That knowledge never disappeared. It was written out of the manual. It was waiting. And once you build one layer like this, the rest of the house starts looking different. You notice where afternoon sun lands. You notice which wall stores heat after sunset. You notice which circuits really matter when the grid coughs. That is the beginning of self-reliance, not fantasy, not bunker talk. Attention, then action, then one durable fix after another until your house starts behaving like it belongs to you again. If you are the kind of person who believes that real knowledge has been quietly pushed aside to protect someone else's profit, you already know what to do. Hit subscribe, not for me, for what comes next. Because this is not a channel. This is a quiet movement of people who have decided they are done being sold what they already own. I want to hear from you. Drop your state, your hottest upstairs room, and the monthly bill you would most like to kill in the comments. I read every single one, and your answers decide what we cover next. Next week, I am going to show you what a 1946 Penn State document reveals about cooling a building with nothing but shade, damp fabric, and air path. The technique uses nothing but muslin cotton, lime, and water. And the federal guidance from 1949 that proves officials knew how buildings should breathe decades before selling you sealed box comfort. You are not going to want to miss that one.